Here are some more problems from section 10.1, and this again, we want to eliminate the parameter, we want to sketch the curve, and again, I didn't write down the range of values, but this was going to be from 0 to 2 pi. So these were my two equations, my two x equals sine of t and y equals cosine of 2t. So what I did was I made a table and I went by increments of pi over 4 from 0 to 2 pi. So those would be all my values, and then you can just put these in the calculator if you want. But they're all pretty much exact values, and we can round it off. The square root of 2 is about the square root of 2 is 1.4. So the square root of 2 over 2 is about 0.7, so that's why you see these 0.7s or negative 0.7s as they go through the different quadrants. So these are the values you can get, and like I said, you can just put it in the calculator. I put both these functions in the calculator and just use var, y, vars, and just second answer kit was real easy to generate these values and fill out this table. Now when I graphed it, it started at 0, and it and you can see these little arrows here. It's a little more complicated, and you can always check it in your calculator, which is another easy way to do it. But like to see, at least do the tables on a few of these, so I know you can do them, mechanically, and then you can check them with your calculator. But if you do plot this and check this on your calculator, you'll see when you go trace, it's going to go down like this. Then I put these little arrows to indicate that it goes all the way back up, all the way around here like this, stops and comes all the way back there. So that's how we trace that curve out when your t ranges from 0 to 2 pi. So it starts here, goes down here, goes all the way back around here and around there, and stops, and then goes back there and stops right there. So that's how you would trace it on that range from 0 to 2 pi. So there's the graphing part, and then to eliminate the parameter, let's see. Well, what I did was I used my cosine formula, and remember, cosine of 2t is just like cosine of t plus t, or cosine, cosine, sine, sine. So we've got this, and that's what y was equal to. And then I just got everything in terms of the sine, so this was 1 minus the sine squared. So I got 1 minus 2 sine squared of t, or 1 minus 2 times the sine of t squared, and the sine of t squared was x, so I just substituted x in there, and I eliminated the parameter quite easily. And yes, this is a function of x. Okay? So I hope you can follow all that work we did with the parameter there. Okay, so again, we were using our good old two-angle formulas, and then just got it all in terms of the sine, because I knew that I had sine over here, x equals the sine of t, so I could see I could make that work pretty easy. Okay, number 7, they just wanted you to find, they gave you the parametric equations, and they wanted you to find dy dx and d squared y dx squared, the first and second derivative. So we have our formulas, and I wrote them down as we did the problems, and this is number 7. So remember, if we wanted to find dy dx, that's just dy dt over dx dt, and it's pretty easy. Just take the derivative of sine y equals 2 cosine of t. The derivative of that would be, derivative of cosine is negative sine, so just negative 2 sine of t, and the derivative of the sine is the cosine, just 4 cosine of t. And that's just like minus 1/2 the tangent t, so that's equal to dy dx, or y prime. Now the second derivative, that's just a little trickier, because all we do is we take the derivative of the first derivative for the top, so we take the derivative of dy dx for the numerator, but then we just take dx dt for the denominator, so that's the formula that we talked about in the book. Okay, so this is what we got. So I just put this in the formula, so I'm going to take the derivative of the top. Sorry about that, my cat was crawling up here. Okay, so again, we just take the derivative of the top. I'm sorry, the derivative of this is the numerator. So the derivative with respect to t of dy dx all over just dx dt. And that's the formula for finding the second derivative. So I like to say it's a little tricky. So we take the derivative of minus 1/2 the tangent of t And we already found this. This was the same. So this is going to be the same in the second derivative. And if we take the derivative, that's going to be negative 1/2. The derivative of the tangent is the secant squared. And then we can use a little trig. And this is just I kind of inverted multiplied. So this was negative 1/2 secant squared, and then times 1/4, and then we just put this over here, 1 over the cosine. And then this just becomes a secant, so it ends up being negative times a positive is a negative. 1/2 of 1/4 is 1/8, and then we have the secant squared here, and 1 over the cosine is the secant, so we have the secant squared times the secant is secant cubed. Okay, so that was number 7. So first derivative and second derivative with respect to x. Okay, I hope that makes sense.